Hi, welcome everyone to C Language Session 6 organized by EOTF for the PG Diploma in AI Study Circle. Uh, Jamit has completed session 5. Some part of it he may have just do an overview from the past. And with that, I will hand over to Jamit Vasawa for the C Language 6 session. Thank you very much. Go ahead.
So thank you for the introduction. Hello everyone, my name is Jamit, and since last session was more on the theoretical aspect of the file handling in C program, so I'll be continuing with that. So we'll be looking at the codes for file handling. So yeah, so it starts with this one. This is the whole simple program for opening a file. So we have our including the header files with stdio and standard library. Then the whole main for running program. So we define this for as a pointer for reading the file. Then we'll use fopen for opening a file. If it not, it will create a file. So I have named this a file as first1.txt, and I'm opening this in write mode. Not so there are three modes. R is read, W is write, and A is append. So I'm opening this in write mode. So after opening this, I'm using fprintf for writing the statement. So using passing the pointer first and then the statements that I want to. So I've just added this text here in order to write it to the file. So when we'll run this, as I've tried and tested it, so it will be already in the file, and also the on the for the programs that I'll be running. So all the text will be in there. So by running the file, it will show this as we are not going to print the output here, but it will be printed in the or it will be changed in the final file. So you can see this is the file, just in case if you are not able to see it. So this is the file as first1.txt. So you can see that it's printing this. I've made this tab for the future use. So that is the reason it's this way. And so it's printing this right now. So after make it print this, I'm using fput s in order to print further for return using fput s function and passing the pointer to it. So that is so that was the string that you were able to see over here. So this is the line that was used using the fput s. Now we close the file using fclose and passing the pointer to it and return 0. Now as we have used here with write mode, we'll be using a simple example of append mode also. We have our header files here, then the main function. We start with file and pointer fp, then fp equals to using fopen to for our file. So we'll be using the same file first1.txt, and we'll be using the mode A. Now fput s to write this statement, and as we are using append mode, so that is the reason written using append mode and passing the pointer to it, and then closing the file and executing the whole program and having the execute 0 for successful execution. So build and run this. and then we'll check the file. So as you can see that we are getting the statement of return using append mode, that we gave it over here. Now we'll be using an example of a read mode. So our header files here, stdio and standard library, then our pointer for opening the file, and which we'll be using for opening the file, our file name is first1.txt, and opening it in read mode. Now we'll be, as we are reading this, we have to we so there are many ways we can do this. So this is one of the way. So char buffer, and then we are having it giving it a size of 8. Now fget s for buffer, then the value of the buffer and the pointer, and it's, if not equal to null, it will keep on reading this. When it become null, it will stop. So after so printing the values of the file's content with the help of %s for strings and using the buffer. So build and write. So you can see we have the contents of our file over here being printed, and so we are using the file. So we are using our file to be read, and also we are printing it over here. So there are many ways that you can do it. This is one of the way to do it. Now, so you can also change the buffer size here. So which will give you an idea how it's being read. So we have given the buffer size of it, which is a good for reading a small file like this, and it almost contains all the characters that are being read. So if we do it for 4 here, then build and run it. Just for just a second.
Are you trying to recompile? Did
Sorry?
you recompile? Did you recompile?
So the thing is,
Yeah, if you
I tried both, but it's not working.
yeah, that's okay. That's okay. You can move on. Actually, that depends on the compiler. If you have the yeah, you can try one. What about one?
Just a second. Let me. Okay.
Yeah.
I think now it will do. Just a second. Okay, it's not happening. But so the
the explanation. Just explain. That's all.
So when we get the buffer size to 4, it will only read this much text, and then it will carry on from this to again again
Four
the
more.
4 more, and it will be
Yeah,
in this order and not continue on the rightmost side
correct.
to it. So that's what it will do whenever we do this. So after, so let's say that we have to write a bigger file or read a bigger file. So what we can do is have this as a one the value of one, and then uh, do it too. Same here. That so this gets the buffer size to a bigger amount, and then helps us to read larger and larger files. And just in case if we are reading a large file, but right now we are only reading for a small value, so size of this is enough. So after this, as we have seen the example of read mode over here, we are getting this. Now there is a program for opening the file, then counting the number of lines, number of tabs, and number of blanks and number of characters in within the file. So it's the same usual, including the libraries here, then going to the file, using the pointer, then character for reading the file and saving them into the variable. Then we are number of line, number of tabs, number of blanks, and number of characters as variables. And firstly, having them as a value 0. Then opening the file, first.txt is the name of our file, opening it in read mode. Then using the while to iterate through the file. So using ch to get fget c, using the pointer, which is if this is not equal to end of file this, then it will keep on running until the end of it. So end of file is the macro that is given at the end of file by while when we read it. So that is used for reading through the file till the end. So as you can see that as this will keep on uh, passing through the characters, it will also increment the number of characters variable here. Then we will have the if statement to check the number of blanks. And as we encounter more blanks, we'll get the number of blank variable to increment with 1 every time we do it. Same for a number of new lines. So we'll be using this to identify it, and then number of lines to be incremented. Same for tabs. As more tabs will be used, the number of tabs will be incremented by 1 as it's done. So then after we have executed this, we'll be using fclose and closing our file and printing out the numbers here. So let's run it. So you can see that our for the file that we have been using, this first one.txt, the number of characters are 182. The number of blanks are 26. Number of tabs, as you remember that I kept a tab over here, this one, just so that it can have a just for the sake of example. So this tab so this tab was counted by it, and to be 1. Then number of lines was 6. So the number of lines are 6 because it starts with 0. Uh, so in a way, you can say that it's 7. So so yeah, this was the explanation for the file handling and a few programs for it. Now let's shift to the operators and different operators in C. So we're starting with the right shift operator. So what does it do? The right shift in C takes two numbers, right shift the bits of the first operand, and the second operand decides the number of places to shift. So most of these operators will be operating with two operands. Then so right shift shifts the bits as by the given value to the right, and the ones on the left, if let's say ones on the left will be filled with blanks. Same with the left shift operator shifts the value of bits into the left side and fills the rightmost side with blanks. So now there is an AND bitwise AND operator or bitwise AND. So binary AND operator copies a bit to the result if it exists in both the operands. So you can see the logic of the AND over here, and the way it operates. So it needs to have both the values as same, else it won't. Now the OR operator copies a bit if it exists in either of the operand. So you can see that if either of happens to be 1, it gives us 1. Then the exclusive OR will be seeing this in details with in the program. So it copies the bit if it is set in one operand but not both. So one's complement operator, so it's basically flipping the bits of zeros to 1. Wherever it's 0, it will be flipping to 1. So here in the example, you can see that A is equals to 0, 0, 0. Then the complement of it will be 1, 1, 1. So also let's see the type def and then move to the programs. So type def, the C programming language provides a keyword called type def, which you can use to give a type, a new name, or define your own data type. So why do we use it if we already have a define function to it? So type def versus define. So define is a C directive which is also used to define the aliases for various data types similar to type def, but with the following differences. Type def is limited to giving symbolic names to types only, whereas hash define can be used to define alias for values as well. So Q, so you can use 1 as 1, etc. So type def interpretation is performed by the compiler, whereas hash defined statements are processed by the preprocessor. So as we have also been using many C libraries, this is just a short explanation to the C libraries that are there, and we can use it. So assert.h, for it checks the value of expression that we expect to be true under normal circumstances. If the expression is a non-zero value, the assert macro does nothing. Then complex.h, then float.h, then limits.h, then maths.h for the mathematical functions. So it has the contents of a square root and stuff. Then stdio header defines 3 variable types, several macros, and various function for performing input and output operations. Then time.h, then string.h, then standard, and there are standard libraries and stuff. Std lib for different functions as well. So now we'll be shifting to the programs of the operator explanations. So first is the left shift operator. Left shift operator. Yes. So first is the left shift operator. So this is the explanation to it. In main, we define a variable num and giving it a value of 5. So the binary of 5 is this. And then we perform a left shift operation by 2 positions. So this is the way to do it. And this is the symbol of left shift operator. We are shifting the left to left shift by the position of 2. So so the value becomes this. And as you can see that these will be the blanks that will be filled as we shift towards left, and then printing the result here. So when we run it, so you can see that the value of 5, as we have shifted towards by 2 position on the left, the value is this is the binary value of 20. So we are getting the value of 20. Now just a second. So this is the explanation for the right shift. Similar to left shift, we are assigning a variable and the value of 10 to it. So the binary of 10 is 1010. Then when we shift the right shift operation by 1, we are shifting the position by 1 on the right. So first the blanks will be filled on the left and the position will be shifted to right. So this is the value of 5. So when we run the program, we are getting the value of 5 and we are printing it using this. So we have covered the left and right shift. Now let's move on to the end bitwise operator. So we have the header file or main function, and these and an OR operator will be operating with 2 operands. So we have our num1 and num2 giving the value of 12 and 25 to it, and having the int data type. Then the binary values of 12 and 25, and we are running the AND operator, and by using the logic of AND, we are getting the value of 1000. So which is the value of 8, and we'll be using we'll be printing the result of 8 using this statement in the result. And this is the way we implement our AND operator. So you can see that it's printing the value of 8 here. Now it's for OR operator, as one of the bits have to be 1, else have to be 1 and it will give us 1. So same variables and same values, and this time we are using the OR operator here and comparing the num1 with num2 and the values of these. So and the value will be printed using the printf statement, and the value that we are expecting is 29. So when we compare the value of 12 and 25 with OR operator, we are getting the value of 29 over here. So next is XOR. The same variables in num1 and in num2, same values 12 and 25, their values. Then using the XOR operator, this is the symbol of the XOR. And when we use this, we are getting the we should be getting the value this in binary form, and for decimal this is a binary binary of 21. So we are expecting the output of 21. So as we run this logic, we are getting the value of 21 for XOR. So now the complements, as it's used for flipping the bits. If it's zeros, it's one, it's one, it's zero. So we are using an int num and giving it a value 10, then saving the value in result with a complement of num. So you can see the explanations over here. That binary representation after complement of this value will become this. So, and we'll be using the printf statement in order to print the result, and the value that we are expecting is -11. So we are getting the result, and that we expect it's -11. Now, the example of type def that we discussed, which is used for naming or defining our own data type. So here it's a simple explanation of type def. So we are using type def for using it as a int being used as distance. So we are basically calculating distance. So we are using int to be named as distance. So in the main function, we are using distance x, it's 10, distance y, it's 20, then distance sum, which basically means int sum, and adding the values of x and y. And we have the value of x is 10, y is 20, so we are expecting 30. It is. So printing the value with this sum of distances 30. So this is a whole explanation for the C. Some for file handling, then bit operators, and then some of the contents of the libraries that C holds, and what are they used for. There are many different things. So this is one way to do it. Same for reading the file, and while file handling, there are many ways you can read a file. And and I showed one of the way that it can be done. So I'll be passing on to Prakash sir for the for carrying on the further explanations.
Thank you, Jamit. Excellent. So we have really covered C language very well, thoroughly. However, some of the elements which are related to Linux, because this use is on the online directly running the program. So I just wanted to share some of the possibilities that we can use. And so I do have what you call something I wanted to explain specifically about inode, and then also look at the what you call the ability to use it on the cloud. Let me see whether I have my cloud. No, I don't think I have my cloud version running. But anyway, let me first share my screen. Am I sharing my screen?
Just
Let me see.
no.
Okay, so let me start by sharing the screen. Okay, share. Okay, I have to share this. Okay, now I have shared my screen.
Yeah.
Are you able to see my screen? Okay.
Yes.
Okay, so one thing I wanted was to find out whether I have my. Okay. not this one, not this one, not this one. Yeah. So I have a Google Cloud here instance, and I just wanted to see whether I have instance running. It looks like I have an instance running, and let me see whether I can get the instance. So instance 2024 it says logging. Okay, let's see whether I have the instance. Yeah, this is the instance. So what I'll do is I'll just try to log to it. I'll have to, I don't know how I'll log to it. Let's see. So this is the instance, and this instance I want to log into. Let's see whether I have the logging. No. So I'll have to do a SSH probably into it. Let's see SSH. So here is the SSH. I can open in the browser window. So I have a Google Cloud instance for a Debian version 12, and I'm trying to connect to it through the browser. So it will ask me the SSH key. Once it logs in, then I'll get the command line for the Linux. Why I do want to explain to you is, yeah, let me authorize it. And then, yeah, I'll get a command line now. So I got a command line now. So I have a Debian 12. So what I can do, a cat command. Cat is nothing. Copy a terminal, etc, etc os release. So it shows that I have a GNU Linux 12, that is Debian Linux 12, which is a GNU is, it's a it's freeware, or it's open source, and it's a name of this distribution is Bookworm. So I have a Debian Linux version 12, and it's called Bookworm, and the ID is Debian, and www debian.org has the support for this, etc. So first thing is, what is this? If you have a Linux machine, you can look at the various by doing a ls command. Ls is list the source what you have here. So it shows that there are two files down. One is, so I can do a detail ls minus lt because I want to know what exactly these are. So download is a directory. It has got a read, write, execute, read, write, execute, read, write, execute permission, and this is for the owner. This is for the what you call group, and this is for others. So the owner is SMS Prakash, the group is SMS Prakash, and others. So this is a download is a directory which is owned by this user ID, and it is belonging to this group, and this as a owner has got a read, write, execute permission, whereas as other it has got a read and execute permission only, and for others also it is read and execute permission. There is no write here. Dash means no, none. And the other one here is a file, and that file is a .py file, that is a shell command .py or something, and this is a file, so this is not a directory. Then so there are read, write, no execute permission. For others, for the second, there is a read permission only, and for others it's read permission only. So this is the permission. Now what is this actually? So the way to look at is, you can say df describe the file -i, which will give you the inode. So what happens in file system in the Linux has got various directories, and the root directory is the one which appears as root. So this is the root directory. All others are mounted on some name like /dev/run/dev/shm/run/log/boot/efi. So these are the file system. UDEV is generally the device system. All devices are mounted on this. So you can have a /dev/ let's say printer /dev/monitor /dev/screen, whatever IO device you want to implement. Tempfs is generally for running. So if you run a program, it uses that. This is the SDA1, dev SDA1 is the root. So this is the main boot disk from where everything is. So boot files are in the /boot EFI, and root is the one which is the main. And you can see the root file system has a inodes. So the inode when I say df minus I, it gives you the inode number. Inode is nothing, index node. So there is a number associated with it, and how much of the inode is used, how much is of the inodes is free, and what is the usage percentage, and what is the name, logical name. So you can see that mount points is the one which is converting this actual physical file system and pointed by this. So if I say ls/, it will give me all the files on the root. It includes bin, dev, home. So usually home, if you do present working directory, you will see the home. So as a user, my home is /homes SMS Prakash. If I add a user Jaimit, it will be /home/Jaimit, etc. So you got the binary which contains the ls/bin. If I say, it will contain all the binary. So you can see all the binaries of this system which can be used. Example, I did PWD, right? Present working directory. So all the binaries are existing there. So if I do a binary PWD, it will tell me that I am in this directory. So all the binaries which are there, executables are under bin. Same way, if you look at ls-alt, you can see that all the, this is because I am on the home directory, it gives me with respect to the home directory. So you got here .ssh download and all the local files. Dot files are all usually for information that are system related, and some of them like .profile, .bash rc, etc. So exactly what I am trying to do is I wanted to explain to you what is inode, right? So if you look at inode, if you go into the find some of these available, you can look at the various things that are available in the what do you call in public. So they have a file system inode, and so a file system consists of bunch of inodes, and one of the inodes represents the file system, and that file system will have mode which we saw, read, write, execute, permissions, owner info, the size of this, and the link counts and the blocks connected to it. So that is what we saw in our, if you go back, when we do a du minus I or df minus describe file, when you do df minus I command, you can see that you got the file system name, the inode, the use file, the free file, the percentage usage and all. So du, if you just say du minus h, it will actually give you in, sorry, not du minus, df minus h, sorry. So if you do a df minus h, you will get the size in gigabytes, megabytes, etc. So you can see that file system root file, in this case root file is dev sda1. It has 9.7 gigabyte. That means what? As a system, it has got 9.7 gigabyte, out of which 2.48 gigabyte is used and 6.86 gigabyte is available. So 26% is used and mounted on root. Root is slash. Just a single slash is dev sda. So device is /dev sda, which is the file system, and the logical name of it is slash, which is root. And so this is how one looks at. df minus h. But if I say df minus instead of h, I want to see in kilo, then it will give me in kilobytes. So blocks of kilobyte it is showing. The same root now, instead of talking about gigabyte, which is minus h, and df minus h, df minus k, and so describe the file in terms of kilos. So it is telling that it's a 1k blocks, and so the root, which is slash, which is the entry number 1 to third one, dev1, you can see that it has got actually 10, almost 10,000 kilobytes, approximately 1008, and then out of which 242 have been used, and then 712 is still not used, and so that's how it is coming. So you can see, and the same way, if I put df minus I, I'll get in terms of inodes. Inodes are actually the same. I'm looking at dev1, which is root slash entry number 1, 2, 3, third for the file system, third 1, 2, 3, dev1. You see 647168. So what does it mean? We are talking about kilo. When we talk about kilo, it is showing as almost 1000, and when you look in gigabyte, it is showing as 9.7, and when it look at here, it's showing 647, because uh, the block sizes are not kilo, they are something more than 1 kilo. So more than 1 kilo means how much that is. So depending on the block size, it can be 2k, 4k, and accordingly the inodes uh, is pointing to a block size of something different. So in this case, usually it is 4, because you say 4. If you look at the UDEV, it is 499, which is approximately 5. 5 into 4, 20. So that is 2 gigabyte. So that means 4 kilobyte is the size of the block. So now what I want to share with you is important to note that when you have a inode, you have got an inode, it has got all the description of the mode, read, write, owner info, size, link count, and blocks. So the block sizes usually for inode differs. You can have 4K, you can have 2K, 1K. Usually in this case, it is 4K as we observed. So that is important to know. So index node, a file system has an index node, inode, and that points, that index has got all the information that points to the different blocks it connects to. So there may be many 4K blocks it connects to. The pointer is always to one of them, represented here on the screen when we saw that, right? So what we saw was, we saw that it is connecting to this. So now what I want to do is, so you have understood inode is nothing but an index node which represents the file system, and file system in Linux has a device name and actual logical name. It is on a mount point, and the mount point is the one which we use generally as the name. So when I say PWD, I know that this is SMS Prakash, this is on the home. So that means what? It is on the home directory, and the home directory is the point where it is on the root. So if I say ls/home, you will find that there is only one user. If I add more users, you will have more users. SMS Prakash, maybe Jaymit, etc., etc. So you got a file system which is represented as hierarchical /home/SMS Prakash /dev whatever. So if I say ls/dev, it will show me all the devices that are available. So you have a loop device, you got a net device, you got a std in, std out, std air, which is what we have used for our simple IO. So you will find that you got disk, you got a floppy disk, you got a what you call log directory, you got TTY terminals, TTY 0, 1, 2, 3, 4. And so your Linux system consists of devices, and those devices have further down the line, depending on logical usage, you have storage. So this is all representation of the Unix file system or Linux file system. So Linux file system is a tree where your inode is the index, and from inode, every node that is derived from that has a node, has a inode, and that's how you look at it. So you got a inode and you got many. So a file system has several inodes. Each inode points to the index, has got the entries, and those entries points to the blocks. So the entire storage is divided into devices and used. And that is why I wanted to demonstrate to you df minus k, df minus k is kilobyte. Described file in kilos, described file as inodes, described file uh, as h, df minus h I had given, which was more to do with the df minus h was to give you the what you call the uh, actual in gigabytes and megabytes and all that. So we have seen ls minus lt, which is nothing but lists the, and now I want to go into download and explain to you some of the file compilation issues which we have not done. So I'll go to change directory to download. So this is a command to change it to download. So ls minus lt. So this will tell you that I have executed some of the programs, and these are all related to various file, how to do a compilation and all that. So what I will tell you is, when you get a Linux box or you get a VM, virtual machine, or an instance of a machine, you really don't know what it has. So if it does not have, example, when I got this, uh, I did not have in this compiler the C compiler, GCC, what we call. So what I did was, I'll just do a more readme is there. Let me hope it is there. If it is there, fine. No, sorry. So let me do readme is there. Yeah, there is a no cd dot dot. Let me just check whether readme is here. No, not here. So cd download. Okay, lsr star. Let me see. Yeah, there is a readme. So what I did was, just to explain you, there is a wiki example. Sorry. So I had, since there was no Debian on this, what I did was, I went to a, can you see the screen here? Debian, how to install GCC on a Debian 12. So apt upgrade, apt install. Apt is nothing but, this is the one which is used for uh, the update or upgrade of. Apt is the one which is the command used for upgrading. But you remember, you can't just do a apt update. If I say upgrade, it will fail because it does not have the permission. But if I do a sudo, sudo is the permission which allows the super user device. Super user is the command. Sudo is allows you to do the super user and then show what it is. Like, I don't want to do upgrade, but sudo just says sudo and then sudo, let's say ls minus alt. I want to see everything of everything. So here it is showing all this. So what I can do, I can do a more and less are the two command which are used for. So if I want to, let's see what are the commands I use. I can use a this way. So you can see all the commands that I have tried, various commands, more than 200 commands I have used. So main important out of this I want to share is for the compiler, right? So I'll just quit here. So more and less are the two commands, which is equivalent of cat. Cat is copy at the terminal. Less is equal to, less and more are nothing but whatever file you give. Example, readme, less readme, it will tell you that this is the last line. Instead of first line, you'll get the last. Less is from the end, more is from the top. So you can do a less or more on a read besides the cat, which is copy at terminal. These are all reading the file. Now, more importantly, why I brought this here, I wanted to say there is a man command, man minus GCC, man minus K. Man is a manual of keyword GCC. So if I say man minus k GCC, this will explain about GCC. So what are the commands that are available? You got GCC for many a thing. Like GCC is nothing but C compiler. GNU C compiler. So GCC stands for GNU stands for it's a open source copyright and copyleft. So copyright is usually you have that is when you this is Richard Stallman of GNU Foundation, who in 1992 I believe he got the copy left idea instead of copyright. Copyright means you have, whatever you do, you have a right to that, and somebody has to take permission. But in the GNU style, there is no copyright. There is only copyleft. That means anybody who can use anything, but they have to contribute back to that. So the idea behind this is how the the Linux and GNU all as an open source, they whatever you take, you give back. That's the idea behind it. And GCC is nothing but the compiler. So I can say that the man minus k is manual. There is a manual, and the keyword GCC if I use, same way man minus k, I can do anything. So I want man minus k manual of, let's say I want to do VI. So VI is nothing but editor. So VI, wherever VI comes, it will give, but VI example, VI improvement, a program text editor. So VI editor is very popular. So if I say ls, and if I say I want to have a file, let's say AI a01.c, I just want to see what does that C file contain. So I'll say vi a01.c. So it says that there is a main program. It has got a int c, it has got print, enter value, get char and put char. So this is nothing but standard IO. stdio, which is standard input output, we saw in the dev directory. So if you remember the ls/dev directory, I showed you the std input, std output, std. These are the devices. These are nothing but file node, file system. So file system has a std in, std out, and so when you run this a dot, so how to compile? So we can say gcc gcc a01.c, which I showed you standard C program, okay, and then I say minus. I don't say minus o, okay. I can get an object file of it. If I give minus o, then I can specify the file. Example a01 dot a01, just or a01.o. But if I don't give anything, it will give by default. If you compile a file, it will give a dot out. So let us just look at, do I have ls a dot out? A dot out. Is there a file called here a dot star? Let's say a dot star. Do we have any file? No, right? So now if I do a GCC, compile GCC, and the file name a01.c, which is what we saw. So let me see ls a star, a dot star. So now what I get? I get a file called a dot out. So when GCC compiled the example more a01.c. So what I have, this is the file I had, and when we compiled this, we got a dot out. So now if I look at, there is a dot out, which is here a dot out, green one. So if I say dot slash a dot out, I'll be able to execute this. So it's an enter value. So I say Q, and so you entered Q. So example, so this is nothing but the std in, right? So we were trying to get a std in. So same way I have compiled various files, but instead of a dot out, I didn't default it. I did everything, like example, I said gcc a01 dot c minus o, which is object file. So object file is generated from the source file. So a01.c is a C source file, and minus o, it has a a01.a. So what I am trying to do is I am trying to get that I will overwrite a01.a, but this is the file it will generate. So if I say dot slash a01.a, it will execute it and enter value. And we entered the value q, if you remember, same thing. So a01.a, a02.a, a03.a, all these are compiled files. The green ones which are, so I can do one thing, file, and then star dot c. So what it says, these are the source files. C source, they are ASCII files. This exercise 06.c is Unicode file. So we got 01, 02, 03, hello.c, read a file.c, write a file, writing a file.c. So I have the course source codes. So we can see like more or less or more, it doesn't matter. Or we can do cat also, it's not a big deal. So let me do less because I don't want to go too far. So let's say read a file. Or let's see, let's hello.c, which is simplest one. Hello.c. So what do you have? You have this is the right hello.c program. I can quit, and similarly I can do less on, let's say read a okay, read a file.c. What do you see? Here is the file pointer. So the what Jamie had done, same thing with a file pointer with a buffer of 255. Open the file, and this is in the /temp/test. So temp is usually used for temporary in Linux, and so you can put any file in and you can forget about it. It will be cleaned up later. So or you can clean it up anytime. So here is open fscan and printf, fget and print, and you get the file pointer. So example of this is reading a file. So let's say q, and let's look at ls tmp, and what do we have there? So you got in the tmp, you got many things. There is a test.txt, right? So I can say cat copy at terminal, or instead of that I can do a less um, tmp temporary directory, which is part of the file system. Okay, and temp directory has got this file, which is where this is a testing for fprintf, this is testing for fputs. So what I wanted to show you was that we have file and we have the programs, and various programs are there, and each of these program, whatever were done by Jamit on the what you call the uh, web browser, the same things are available. So so let me first do a writing a file, right? Write. So let us say we want to execute these are, so when I did a file star.c, I saw same way I can do file star dot, I want to say all the object files here. Okay, star file star, let's just say file star. Then what happens? You get all the files. So all the a dot out, a01.a, so elf. So instead of that, let me just say star dot a to give you a picture of what are the a01.a is the object file generated by, and this is a elf. So that is a format, and these are all 64-bit, and ELF is a binary format for Linux object file format. ELF is a file format. So you can see this is a x86 executable, and it has a system 5 dynamically linked, interpreted with library and all that. So all these libraries and builds, etc., are everything is shared here. So you can see that 1, 2, 3, 4, 5. These are the file. And same way, if I do ls a dot out, it should have not ls file a dot out, which is the default. Sorry, file, made a mistake. File a dot out. This is the binary output. So this is very similar to all this. They are LF format, 64-bit LSB first, and it's executable, and it is etc. etc. So the inode, important point is inode, and inode describes all the information about a particular file. So the file can be source file, can be an object file, can be executable, can be a text file, can be ASCII text, can be a Unicode. Example, I say more instead of that less. Let me say less. I just want to see what is that exercise which I have given. Okay, so here it says binary IO function. So you can see that I have used the C++ slash slash and not the slash star star slash. Uh, so I use both of them. So to binary, so you remember you had a binary input output format which was there uh, in the last class Jamit had described. So you can write a file in binary and read in binary. So the exercise I have left out is you create an array or a structure and then write a file which is to temp array struct.txt and read back. And this can be done using the commands using the size t fread and size underscore t fwrite. So fread fwrite commands can be used to write binary, and when you read or write a binary, you use it for generally structures or for the arrays. So this is left as exercise. So what I have is you can see all the source files that are there. I'll just read it for you. I can do it through less, or I can do less is better because I can get back to the screen. So what I have A01 we had done A02.c. What does it have? This is a file for enter a value using getters and print a value using printers. And the code for that, if I do a gcc minus A02.c minus O A02 dot A, it will give me object file. So you can similarly do for various things. I'll just keep on printing so that you know what exactly uh, Jamit had done, and I'm just trying to back him up with what files. So this is for the uh, string of buffer 100, and then you are printing and scanning and printing back. So whatever you entered, so it shows you enter a value, prompts you, you scan, you whatever string you give, it collects it in the str buffer and then prints the buffer. So this is one of the programs which is for string input output. Then similarly we can do another file A04.c. So what it has is, sorry, A04 is not there. Okay, so there are only 3 files. After that I have got only files which are related to read and write. So I can just read file and write file. I'll just give before we close. So here is the read file and .c file, source file. So it says main. It's a file pointer with a buffer of 255, and you do a open on a temporary file test.txt, and then you scan to get the value, and then you put fgets, and then you do a read. Since you are doing a read, this is already existing file, so you are just reading fscan, printing f, and uh, putting out on the screen and closing the file. So this is for read, but prior to that we should have done a write. So how did you, if you don't have a file, you will not get anything. So if you do a write, this is nothing but main file pointer is fp, then file pointer, you open the temp file, you do a write plus, means if the file doesn't exist, still you create one. If it exists, just append to it, types or overwrite it. So here you got, this is the testing and put and close. So this is what it was executed before. Once you execute this, then you read it. So write first, read later. So that is the temp file. So these are the various programs which I uh, showed you on the Google Cloud with a uh, compute uh, instance. And so uh, you can download these files, and that way one can provide. So I'll provide you the list of files that are there already written here later, and that will be available to you for to check it out if you do anything. and how to do a Google install. And so this brings to end the inode, which is what I have shown you from the public s- uh, Google search, that you can have a file system, and the file system is the most important thing. And what I have done is, in the Linux shell program, I have put a Linux tutorial so that you can go through the various things and whatever we did on the inode. And so if you want, you can go to the C input. Here is one which is nothing but the C file IO, and this tutorial is available. And so this brings us to end all that cool stuff we wanted to cover under C. C not only for C on the uh, general C, but also on the Linux C. Hopefully, because most of the Jamid has been using on the browser based C, and this is nothing but what we thought is a cloud based compiler using a compute instance on the Google cloud. So hopefully this gives you sufficient to cover on the C. I think we will end this with exercises, which one exercise which I had provided to you. And Jamit, anything more you want to say?
Yeah, I just wanted to correct the code that did work.
Hmm. Yeah, go ahead.
Just a second, let me share the screen first. So can you see? Hello? Can you?
I'm muted. No, I'm muted, so I can see. Yeah, sure.
Yeah. Okay. So the reason it didn't work is because we changed the buffer to the size from 8 to 4, but we didn't actually uh, made a new line character here. So what was needed was when we were printing the buffer, we had to use this in order to always uh, get back to a new line whenever the buffer size is over. So that is the reason it printed all in one instance. So now if we run it, you will get the output that we wanted. So this is the way it will do if the buffer size is 4. But if we do it as we did before for buffer size 8,
Can you show the run? I didn't see. Oh, so run is at the bottom. Okay, got it.
were you able to see it? Just a second. Let me change it.
Yeah, yeah, yeah. It's run it and show it. Yeah.
No. Actually, instead of entire screen, I shared just a window. So that's the reason.
Oh, okay, okay, okay. Fine. Correct.
Okay. Are you able to see it now?
Yes.
Okay. So first, we had this as the value. So this was the whole program, as I discussed before. And then when we changed the value of 4 of buffer, then we had to add the new line character in order to change every time the buffer size is uh, accumulated and shifting to a new, getting the new values. So this is the way how output would be uh, displayed if the buffer size is reduced to 4.
Okay, four
But
character.
yes,
Okay, got
but
it.
if we do it for 8, the
Mhm.
way we did it, then we will. Oh no, I don't know why it happens.
No, that's okay. That's okay. I think you're okay. It showed what you
Yeah.
wanted to, so now
So
it is correct. Yeah,
so this is the normal one that we did it with the size of buffer 8, and
yeah.
after this,
So,
if we
so it is not the 4 or the 8. It is how you print out. In the
yes
printout, since you
yes
did not have the carriage return, it did not
yes
terminate after 4. It continued the buffer as long as it could get.
yes
And so So that's okay. So you have shown the difference. Yes,
Yeah.
it's very good. Fantastic. So you are on the spot debugger yourself now.
Yeah,
Fantastic.
I forgot it when I was presenting it. I didn't
No,
see
no
it.
problem. So do we have anything more on the C, or we just end this session on C
No, no,
and go
nothing,
on to data?
nothing more.
Yeah, good. So I think we are ending this session. I'll stop recording, and next time we'll be talking about data structures and algorithms, whichever way, algorithm and data structure or data structure and algorithm, whichever way. Okay.
Okay.
So let me stop recording, and thank you, Jamie.